is the recorder. I will bring that page up again. But on that whiteboard, the little whiteboard, 45, 46, 47, 48, talk with your partners. Which one is A, B, C, and D?
On 45 is C.
46 is B. I think 46 is B. Because there's zeros not undefined. Take this marker here.
Yep.
Yeah.
No, 46 and 48. So there's like the ones that are like an edge, like kind of like and I think the
And then 0 to 5 is D, and 47 is the one.
yeah, no, D is 47.
Yeah, I don't know.
It's just B and C.
My mind didn't, no. My mind was there, but my brain didn't like raise.
Common use up. And it's being recorded. Okay, so
48 is D.
this is what I saw on I think every card. You guys agree? All right. So yeah. What's a critical point from last time we were here?
Isn't it any point where the derivative is undefined or 0?
Yes. So anywhere that the derivative is, first derivative is undefined or 0, that's a critical point. And if you look at it in these particular graphs, critical point, because it's undefined, that's a local minimum. Critical point, because it's undefined, hey, there's a local maximum. Critical point, because it's 0, there's a min, there's a max. 0, max and a min. Min and a max. Does it have to be? Nope. Could hit 0 and just keep going. So just want to put that out there. And for those of you who are, there is an assignment due in like 9 days now on AP Classroom. Over the course of the year, I will be assigning the student practice, which is basically a free response question. It's a royal pain in the butt, and it takes a lot of clickety-clickety to get through. How many of you are not familiar with AP Classroom and student practice problems? All of you are? Cool. So you need to click through and enter something in the box for what your answer is, and then I want you to check and click the answer box to see what they say is the right answer, and make sure that you're right. There's some that are with calculators, so I'm eventually going to assign all the level 2s. So this is unit 3, which is on derivatives, and I believe it is with calculator, and you need to know how to round it correctly, so make sure to check your answers with what they do. And if you're confused by it, there are videos that you can click per section, and it'll lead you through. Because the biggest issue on the AP exam is you guys are like, I didn't know what they were asking about. They confused me because they put all this plankton in there. There's always some problem that you guys come out angry about. The stupid baked potato, I don't care, I don't like potatoes, I wouldn't eat a baked potato, I don't care when it's cool enough to eat. I'll never bake, I don't care how hot the cake was, I'm never gonna ice it. Or the diver jumping into a pool full of plankton. There'll be something, they'll come back and complain. All right. This one's quick, right down on the board. It takes you 2 hours to go from being parked in your driveway to being parked at your lake house 110 miles away. What's your average rate of change? Write it down, just the same, write it down. Just the answer. Okay, I like that people are giving me units. Yeah, all right, 55 miles per hour.
Okay, we can write that.
Yep.
So what time are we doing, or what is my instant speed at 71 minutes? Is it 55 miles per hour?
Maybe, could be. Could not be.
Actually, you could have sped up and slowed down.
What?
You could have sped up and slowed down.
You could have sped up and slowed down, like,
Could be 0.
by having an average of 55 miles an hour, does that mean I'm doing 55 the entire 2 hours? No, as a matter of fact, that can't be, because I started off parked, and I don't know, I can't be going 55 miles an hour parked. So I had to be doing faster than 55 at some point if my average, starting at 0 and ending at 0, my average was 55. Do I know how fast I'm going at 71 minutes? No. Okay? That's not answerable. However, this one, I want you guys to write down 16, 55, 60. Yes or no for each one.
Yes, 16. Yes, maybe.
I think, yes,
I know that's 16.
yeah, at some point you will know. Or yes.
Oh, yes, it could be 0.
Yeah, so it's not common 2 hours, maybe they like sped up really fast and just stuff that like, I don't know.
So if you're doing 60 miles per hour, you'll still be going 60 miles.
Yeah, it is. It's imagine you had teaching class.
Okay, so people are saying,
No, I was trying to take 8 classes here. I was teaching like a month late. That's how I got into class. Like I switched this class like right like a month before.
okay, so the question says, is there a time when you absolutely had to have been doing 16 miles an hour? Absolutely yes. To go from 0 miles an hour to 55 of an average, you had to cross through every mile an hour between here and then. 55 miles an hour. Did you have to be doing the average at some point? Yes. Now what's the right answer here? 60 miles an hour. Is it no or is it me? No, because it says, did you have to be? You might have been doing 59 and a half, skirting along the whole time to make the average come out to 55, but you didn't necessarily have to do 60. Okay? Okay, all of this is getting down to mean value theorem. So can you guys get a notebook out? We want to try this. All right, so AP exam is obsessed with a few things. Tan inverse, mean value theorem, fundamental theorem of calculus. Okay. Fundamental, keyword, fundamental. They think that one's pretty important. So, mean value theorem, they love it. And the big deals with this, if you have a continuous function over a closed interval, and it is differentiable over the open interval, there has to be somewhere in that interval that your instant speed equals your average speed, or your instant rate of change equals your average rate of change. Has to be. So your average speed was 55 miles an hour. You had to have been going 55 miles an hour at some point. All of the points at 71 minutes? No, not necessarily. Actually, having a problem. Preguntas?
He's a good teacher.
Question?
She's nice.
She's nice.
Group 11. No one in it. Okay. So average. What does this look like? Slope. Yeah. Slope. Changing Y over changing X. All right, can I turn the page? Hayden, what are we doing? Not looking suspicious there at all. Mm-mm. Did notice the Chromebook come out. Was wondering why. Mm-hmm. One under the notebook? I don't know. All right, so here's our first problem. It says show that the function satisfies the hypothesis of mean value theorem. So, Katie, what needs to be true to satisfy the hypothesis of the mean value theorem? Okay. Say that again?
Just say differential.
Well, but there were differences. You had to be continuous over the closed interval 0 to 2 and differentiable over the open interval 0 to 2. Okay, y equals x squared. Is it continuous everywhere? Like all of the numbers that ever were numbers, so it's continuous over 0 to 2. Is it differentiable over all of those numbers? Yeah, okay. So those two conditions are now true. So find the average over 0 to 2, find the derivative, and find when does that derivative meet the mean value theorem's conditions? So, what about, yes, solve it. And I'm gonna ask you guys, recorder, to put it on a little whiteboard for me. What x value is where the average equals the instant?
Is that just C?
No, it's the average.
Yeah, I got one.
Oh, no, 2x. That average. You can divide
Yeah, that makes sense.
Yeah. I just plugged it in.
Yeah, no, I plugged that
Wait,
in.
I
I plugged that in and then I got
Okay, so this is
like 2x
actually-
would be the kind of so what's this? Do I see how it's equal? I don't know that.
Well, I can read that. And then is, what if this?
Which X value? Because the average,
I'm going to shoot up.
oh wait, right side on the board.
Okay, what'd you guys get?
Right, quick
Okay.
analysis on
What'd you guys get, Haley, your group?
the board and required
What was yours?
Oh, whiteboard.
Okay, I see the right answer on most things, and then I see unfinished answers on some, and I see wrong on some. So, what is the average?
On big words. This is a big one. I'm reading about literally. rolls up.
The average is 2. Logan, what is the derivative?
The derivative is 2x.
So in the land of labeling work, the derivative is 2x. So what x value makes the derivative equal the average? Solving for x equals 1. Some of you just had 1. Tell me it's x equals 1. Some of you just did the work to show me the average, which that's needed, but it's not done. So where now that we've established, Kaden says, that it was continuous over the closed interval 0 to 2, differentiable over the open interval 0 to 2. So then we find the average, we find an equation for the instant, and where are they equal? Solve for the x value. So what this means, here's that piece of the quadratic. The average is the line connecting the two ends. And it means there had to be a tangent somewhere in the curve that the slope of that tangent is exactly equal. We can have more than one answer. Wiggle, wiggle, wiggle. Here's the average. Looks like there might be 3 answers where it works. Makes some sense. Kaylee, you look distraught. You okay? You sure? She looks not happy. Okay. So take 2. Try this one.
Okay, if this writer writes it on the blackboard, it was like write it on the big boards. I don't know if this is a big board. I just know it's orders to write on the big board, so I don't know.
Is this continuous or just?
It's gonna be negative, and then it's gonna just turn out to.
No, but does it apply? Doesn't apply.
So this may or may not be right, because Nico, what's the issue going on here?
The mean value theorem doesn't apply.
Okay, guys, mean value theorem says, I guarantee you there will be a place that the average equals the instant. If it's continuous over the interval, over the closed interval, it is continuous, but
It doesn't apply.
because it's not differentiable
Yeah.
over the whole interval. However, because I made the numbers nice, there happens to be a place, Colin, what'd you guys get?
We got x equals 8.
X equals 8. Right at the end. Right there. The average does equal the instant. Was it guaranteed? No. If I change the problem. So Hayden, this is the point of why there was a distinction. This one now, it is guaranteed. So Nico, you catch this distinction. 0 to 8, it is still continuous over the closed interval 0 to 8. On the open interval, now it's differentiable. So that one, I do guarantee an answer for that looks like it's some weird place in there. But 0 to 8, I guarantee you an answer. Cube root. Is it actually a 2? Could be. Okay. Now completely different. You guys know what it means for a function to increase, right? The y values are getting higher. So this is the irritating math way of saying it. So Jacob, it's saying, gee, the function is increasing.
Is this writing down or is it?
Well, you tell me. Is it? It's, we're calling it increasing when the x's are getting bigger, the y's get bigger. Like as you take a step down the line, for all those x's, the y's are getting bigger and bigger. Or it's decreasing as you take a step down the line and the y values all get smaller. Is there some math or calculus thing that I can do to figure out, are the y's always going up or are the y's always going down?
Yep.
Okay, what? Slope. How do I do slope? So, on a quiz or AP exam or multiple choice question, if you are asked, give me evidence why you know this thing is increasing, you do the first derivative and say, first derivative was positive there, so it's increasing. Second derivative was negative there, so it's decreasing. This is what, when I say justify, this is what I'm gonna need. So, scribe people, get ready for the next problem, because you're gonna be putting it on the boards around. Hey, you ready? Yeah, recorder gets to write on the baby board, and scribes gets to write on the big board. So, find where the function is increasing or decreasing. Okay, so when you are done as a group, group 10987 over there. Group 6 over here.
Oh, plus or minus.
4, 3,
Plus or minus.
2, 1.
Wait.
Zero.
Oh, that is great.
That's just
Put this back to the regular equation.
No, you plug it into the,
No, definitely the regular.
I think, oh, because I thought it was like.
Oh,
Yeah, it's just slow. Yeah, but if you still have negative,
yeah, that's positive, negative, positive. Increasing from. Oh, wait.
So you gotta chef up over there. Thank you, bro. Appreciate it. Yeah, and then I have increasing on less than 2, increasing on 2
Okay, so group 1, group 2, Group 7, you got stuff to put up.
Good.
Okay. Group 1,
Oh, I see. We have specific spots.
sorry, yes, specific spots. So that I know what group to call out. Sorry, Aubrey, we're gonna just change the top number for you.
Yeah. So I've moved and I
We need to show our work, bro.
Generally, you need to show work.
Cause I made it out, stay here, show work.
So where do you
Next to the wall.
Oh,
Yeah. It's bad.
Wait, so what's quick?
5. I mean, yeah, but you got it all the way down.
Oh, we can play 5.
I get home, so you what time you get home? Whatever. You live close?
But no, like I'm just staying back the way you know, I can get home.
Yo, I could be like a whole number.
Oh, so then you wait, so why was the like the
No, they've, I just wasn't in yet because they wanted to review my documents and have the new school. They just didn't stay here.
So they thought that like I was going to be
Yeah? What?
so I had to like rush to like get like it's probably crazy.
I'm sure it doesn't check.
I've been going
Alright, so look at what people did.
What?
You got like full send.
So, generally, yeah, I wanna see work. So, people showed work in different ways. Some people, let's see, first period, there were 2 different ways of solving for the x. Some people factored, like Common did over there, and some people just did what I did. Well, I didn't do either one, I just said, I'm brilliant, I know the answer. So you could set this and get x squared minus 2 equals 0. So x is plus or minus root 2. So you guys can sit down after you're done putting things up. But one thing that I do see that
I was testing.
every single group,
And you did. You guys met.
so number lines, guys. Number line needs a name. What are you testing? Like, name. Okay.
It's just like a mental health.
Isn't it just a mental health thing? No. Because eventually, you might have 2 number lines, one's for the first and one's for the second derivative, and you need to know what you're testing. So, when you put the number line and you're like, oh, I need to test a number in this interval, I'm gonna pick 0. You plug the 0 into the function, or the first derivative. The reason I'm having you name it is that you know what function to plug in. So all of these on the board, thank you for having the number line and having correct values on everything. But yeah, they all need to be named. F prime. And just giving you better habits so I have to waste less. I've already downed 2 red pens since the beginning of the year. Dead soldiers, more than 2 actually, but 2 brand new ones. Gone, dead, exhausted from the adventures of saying things like, label your number line, label your work, tell me what this is, don't just leave like stuff, schmutz hanging around, no floating arithmetic. Hate that, label your work. So, but otherwise things look great. Your textbook, oh, and you can write things like this as inequalities, as long as you're not doing something like 7 to 10 and 19 to 83. Some of you have been writing this notation. I don't know what that is, and it's bad and it needs to stop. On the last test, I wrote on it, you will lose points next time. Is that you, Ben? You're like, So these, you need to be able to specify, are the endpoints included or not? I need to have it clearly marked, which interval notation and the inequality notation, there is a way to indicate square bracket or round bracket, an equal sign or not. Your textbook and the AP will accept it with square or round on these. I personally find it offensive, because if you put a square bracket here for increasing, you need to put a square bracket there for decreasing. So at negative root 2, it is both up and down at the same time, which I don't know what that is. I find it offensive. I don't include it, but they accept it. So. I prefer round brackets for the intervals. But if it's like, what's the domain, it's very much depends on, is it colored in or not. Okay. What does this say? First derivative is 0. What kind of line do I have? A what? A straight one? They're doing a straight one, like all lines are straight. But they're saying horizontal. Yeah, okay, so if the first derivative is 0, what does that mean about the equation of the line? It is a horizontal line. Do I know if it's y equals 5 or y equals 2 or y equals 7, negative e? I don't know. Okay. For those of you already doing integration, this is trying to get us there. So if my x and y axis, like, what's the derivative? The derivative is 0. Okay, so the original function had to be some kind of y equals c. Could be a negative c, or a negative value. C could be negative 3. But if the first derivative is 0, gotta remember there's a constant. Yeah? Cadence, thrilled. Yeah, there it is. Okay. Do you guys have questions from, we did the homework yesterday, we talked about that. And I also remind you of the AP level 2 question. Those that were in class yesterday, they got to start on it. The rest of you, it's due the 26th. Hayden, no, sir. Tonight's homework is day 30. So we are skipping a little bit. But I wanted to look at the pieces of the homework that I'm skipping over. This one's ripe and impossible. It'll be fun. You don't know which one I'm talking about. So the instructions for this, find the extreme values. Quick question, is that x or is that y, or is it the coordinate? Y values. Okay, so with your group, find the extremes. Where are you getting 0? Yeah, you know what? Because put it on the label sheet. This is the correct amount. Oh, that's not. Then we're setting it to 0. And then, what is this? Like, a positive and a negative root two. The number line, as they do here, the test.
Yeah, and we're
Just
gonna
gotta
find
do
them.
chain of
You can't label what you're doing.
This is the derivative, right?
Can I just get rid of this line? Yeah.
Oh, you
Just one. No, I don't think so.
I could work with negative 2x plus it. Okay, so.
Hey, how would you do this? I guess you do 2 minus 2.
But then how do you figure out Wait, it's never gonna be
Of course not.
Yeah, it's never gonna be. No, unless the top is this.
Or you could do like 2.
I don't know, this is probably not good.
Yeah, I got that.
Because you're right.
X equals negative.
I don't use 0. I got
That's crazy.
I just saw. That's not. Shitting on nice guy. And you know, nice guy, you call him for a C on the integral.
Yeah.
Yeah.
You're right.
You're allowed to do that? You just do it at the bottom.
Do what?
You can just multiply that to 0.
You're wrong.
How do I figure out where it's undefined?
You said the bottom.
Where
equals
the
0.
derivatives, okay, so it's 0 at x equals 1, but when, how do I, what do I do, what were you saying? What do I do with the bottom? There's a denominator of the derivative. Multiply by the power, lower the power, and then multiply by the derivative of the stuff inside. I got x values down there, and I got a square root. So I'm not allowed to divide by 0, and I'm not allowed to do square roots of negatives. How do I do this? This was one of the more challenging things in pre-cal that we did for a hot minute, about 5 minutes. Okay.
Undefined on X is like greater.
When does that equal 0?
X equals negative 1. X equals
So let's check, make sure it works. 3 times 1 is 3. Then I have 3x minus x is 2x, negative x squared. Okay, so that all worked. And x equals 3 and x equals negative 1 is where it's 0. Okay. How do I name the number line? F prime? What numbers do I put on the number line? Okay. Okay, putting in 0. When I put in 0, I get a 2 up top and some positive number on the bottom. Putting in 2, I get a negative up top, but what do I get in here? 3 plus 4 minus 4, so negative up top, positive on the bottom. Putting in 8,000. Up top I get a negative number. What happens in the denominator? I get a negative number under the square root. So this stuff is out of the domain. It wasn't part of the domain in the first place either. I can't square root a negative, and I started off with that. So those numbers were never allowed to be the domain before we started, so we gotta look at it now. What about like -8? Does it work for -8? So plugging in -8 up top, cool, whatever, that's gonna end up being positive, but plugging in a -8 down here, does that work? No. All right, so what are my extreme values? Where could they happen? Do I only have a maximum at 1? Because it goes up and then down. Could have what? Check. So you plug your x values back into the function or the derivative? The function, the original function. And? So it asked, find the extreme values. Are my answers -1, 1, and 3?
No, those are good.
The 1 is a critical point. -1 and 3. Oh, error, critical points.
But are they also all these values?
So the extreme values, the all-time is 3 or 2, and the all-time absolute min is 0.